Okay, good morning, good afternoon, good evening, everybody. Welcome to this seminar with the subject how DCM can be helpful in your daily operations. So today we got two people presenting. So first I would like to give Rick the possibility to introduce himself. Rick?
Yes, thank you, Martin. Hi, everybody. I'm Rick. I live in the Netherlands and I work for Mitsubishi Electric as a Director Data Center Application Engineering. Previous I was working for Interaction, which is a large co-locator data center sites in the Netherlands.
Okay, thank you. So my name is Martin Matze. I'm within ATS Global Business Development Manager for Data Centers, and I'm active in the data center world since 2007, and I have over 200 data centers as relations. So our agenda for today, Rick is going to start from his viewpoint of interaction, how his daily interaction did look like. Then just one slide about Mitsubishi, one slide about us, and then some slides about the real subject, how I'm going to choose the right DCM, and what can I do to help you to improve your daily operations. And at last, of course, something about the solution and some references. And we're going to end with some questions and answers if there are any. Rick, it's yours.
Yes, thank you. So, like I just mentioned, hello everybody, I'm Rick. I work for Mitsubishi Electric since 6 months as a Director of Data Center Application Engineering, where we are building our way towards the data center market with all of our solutions. Before that, I was working for 14 years in Interaction, which is a large co-locator in Europe, and I worked there for the Dutch entity. I started there as a site engineer 14 years ago, walking around in the data center. And if you go to the next slide, then I'll explain a little bit about how we started at Interaction. Because we started at just a rack level. And then when I was walking around in the data center, I found out actually that I needed more visual on all the hardware that we had. So we started at a rack level, then we added cracks, and we added chillers, we added power meters, the leak detection, sensors, generators, batteries, UPSs, fire detections, pumps, and ATSs, and hybrid dry coolers. And all that together, I really was looking for a solution that could give me a complete overview of everything, because every time we had an alarm or every time we had an incident, I had to go around into the data center and look for which devices are having issues, what's connected to those devices, where is the original incident coming from. Maybe a failure in a crack unit can be coming from a faulty PLC or something in the chiller that's giving problems with the crack unit. So I was really looking for a complete overview that could help me gain control over our data centers. So including alarming, SLA management, reporting, billing, a view on PUE and EER to make the data center more efficient. So in the end, it became a complete DCIM with everything incorporated from EMS and BMS point of view. And it really helped me a lot to gain control and give a lot of insight into our data centers. We started at one data center, but quite rapidly when we added all the devices, we added more of our data centers. And in 14 years within Interaction Netherlands, we've added more than 10 data centers into the system, which helped us gain more control, make it more sustainable, give very good insights on our reporting and billing, where we've actually made it so much better that we got a lot of refunds on money that we've lost previously when we didn't had all the insights. And it really helped me as an engineer, as operational responsibility, on making sure that our data centers were up and running. So we had almost no outages in the Netherlands during those 14 years. And I think that's mainly because of this system that gave us all the insights and made sure that it's running how it should be. If you go to the next slide, Martin, then I'll tell a little bit more about our proposition from Mitsubishi point of view, because when I joined Mitsubishi, I joined it with a similar thought. From the DCIM point of view, I wanted to have an umbrella view on all of our data centers to make sure that everything like capacity management, alarm handling, contract management, preventive maintenance, all were completely covered under an umbrella. And from Mitsubishi point of view, we are now doing the same. So from one entity, one company, we can offer a complete solution, software and hardware related, where we have, of course, our DCIM together with ATS, which is based on our Iconic system. We have our PLCs and a control network, control equipment. We've got our medium voltage switchgear. We've got our modular and scalable UPS solutions. And we've got the low voltage switchgear, and we can offer a complete generator solution with our partners and a complete IT cooling solutions with chillers, cracks, air handling units, fan wall units, stuff like that. So the goal of Mitsubishi is to offer a complete solution with everything incorporated, so you only have one company to work with, and of course we'll work with our partners and system integrators to make sure that you're getting the best solution in your data centers. Please feel free to ask me any questions about my time at Interaction or about our Mitsubishi solutions. At the end, we will have a Q&A about it. And now I'm happy to give the word back to Martin.
Okay, thank you very much, Rick. Thank you. So my name is Martin Matse. Like I said, I'm the business development manager for data centers within ATS. And I'm active in data centers since 2007, which I already mentioned before. So looking just one slide about the company, and then we're gonna go into the subject themselves. So ATS, we are a technical system integrator, and if you look to the left side of the slide, you can see our areas of knowledge, and of course data centers is a very important one, especially for me, of course, and hopefully also for you. We have offices in, I think, 28 or 29 countries, 1,200 people, and we started the company in '86, so we're quite already for a while there. Okay, starting. So suppose you are responsible for a data center, and you have some things you want to improve. So you want to automate your invoicing, you want to do something with your asset utilization because you have some, recently had an outage and you didn't know why, so you want to decrease that risk. You're spending too much money, so you want to manage or actually your CAPEX and OPEX, so reducing your OPEX. You want to and OPEX is done by reducing costs, so improving your performance. And there are some new legislation coming, which is actually there, almost in place. So the Energy Efficiency Reporting Directive, the Corporate Sustainability Reporting Directive. So your conclusion is, okay, for this, we need a DCIM solution. Otherwise, how are we going to manage all those things? Okay, which DCIM solution you're going to choose? Well, this is something I see quite often. As a vendor, we got an RFI of an RFP, and we have to fill in a compliancy list. And sometimes this compliancy list has even over 250 different features. And you have to say, well, we comply, we partly comply, we do not comply. And sometimes you can add something, okay, we partly comply, but blah, 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 blah. We have to fill in some IDs. And how does it work? We fill in that RFP or RFI, we send it back, and many data centers just do in feature count. They count the number of features, and then given the number of features, they're going to decide. So in this example, we have three vendors, and we have functions like invoicing, performance, capacity, and several more. We add them all up, and you can see that vendor 3 had 14 compliances, 1 partly, and 0 non-compliances. So clearly, the winner of the future count is vendor number 3. So we're going to choose vendor number 3 because he has the most features, and I think he's a very safe choice for you as a data center. But my question is it the right vendor? Looking to this first line, invoicing, there are 3 vendors, and they all said we comply. So looking just at the subject, invoicing. So invoicing is actually very, very simple. So we take the kilowatt hour value at the end of the month, we subtract the kilowatt hour value of the beginning of the month, we multiply it by the rate, and we got the invoice data. So this customer in the co-location side rented 9 racks. These are the sum of the end of the month values. This is sum of the beginning of the end values. So in total, he's been using 12,600 kilowatt hours multiplied by his rate, so 25 cents. So he will paying $3,150 every month. So every year he will paying $37,800. So actually, well, invoicing is very simple. That's covered. So actually, it's not difficult at all. Next. Okay. Did you see that something was wrong in the table? And actually, if you look to rack number 6, the kilowatt hour value wasn't counting up, but he was counting down. And what we notice, if you look to these numbers, he was counting down with 1,800. So that means that you have missed in this month 3,600 because he should be counting up with 1,800 instead of counting down. So we've missed 3,600 kilowatt this month, which was not invoiced. So the invoice we did send to the data center on yearly base is $37,800, should have been $49,500. So you lost $11,700 just on this one account with 9 racks. So if you look to your turnover, you lost over 30% on the customer. Okay, now we know that we're gonna make a little database application so that we'll check if the end value and the begin value hasn't have a negative value. So now we have it covered. Agreed? Let's go to the next slide. This is another issue. This was one of my customers. He came to me and said, Martin, I have the following problem. In my data centers, I have, well, they had a lot of co-location sites. I have around 30 people, and they have only one task is check invoices, and because many things are wrong. And he said, this is one of my big issues. So what's happening? He said, my customer is coming to me. He says to me, okay, I like a proposal from you to rent me 25 racks for 4 kilowatt per rack. So there will be 100 kilowatts. So I'm going to send it a proposal, and then I'm going to talk with the customer. And he said, well, actually, it's a very good proposal. I like it. So, but I make sure I get the signatures. Can we already start? So he said, okay, I will give the instruction to my operations. Please make 25 racks available for the customer. And this customer starts using 25 racks. But then what's happening? The customer says, well, okay, I've talked to my management. We're going to start with 15. And here's a signature for 15. So that's received by sales, and sales sends it to finance. So what's the reality? That the customer is using 25 racks, but is paying only for 15. So there's another issue you have to cover in your invoicing part. This is data center, new data center, very straightforward. So we have those PDUs, power distribution units, standing at the wall. We connect them via bus bars or whatever. We have those PDUs, again, power distribution units in these cabinets. And it's very straightforward. It's just having one PDU into one rack attached to the PDU at the closet. But as you might know, as a data center owner, there are many changes every day in a data center. So after a while, the same data center looks like this. So this one has a redundant feed, this one has a 3-phase feed, and this rack is split into 3 customers, a half rack and 2 quarter racks, but it's also coming from another PDU. And the difficulty is to get everything managed because, okay, attaching, giving a power to a rack is something not so difficult, but having all the administration around it is more complex. So invoicing, the very simple invoicing, what can go wrong? I just created a list of things I've noticed last couple of years, so just give me my idea what can go wrong. Of course, the first one, miscommunication between sales, operation, and finance. That was the flowchart I was giving you, and there's actually no consistency check done during the process. But looking to a power meter, there are so many things that can go wrong. For example, there's only one attached, and the redundant power meter is attached to a wrong feed. That doesn't influence your invoicing, but it does influence your uptime and resiliency. It's not correctly configured. So a power meter has current coils, and those current coils have a number of windings. And if you have the wrong number of windings configured in your power meter, it will give a wrong value. There's no customer contract attached to a rack, so nobody is paying for the power. We're using the wrong type of power meters, so it's not a true RMS type, which can result in a 1 to 25% error. So also using the right power meter is an issue. Sometimes you see a power meter is going up all the time, but it has sometimes a very small negative step. This all means you have installed the wrong current transformers. They have a rangeability issue, so the values they were giving is really crappy. Sometimes you see a big positive or a big negative step, so the bill will be too high or too low. So if you have an application what was looking at a negative step, you will cover that. But did you also cover a big positive step? Because you can imagine if a power meter gets broken, some data centers have 40, 50, 60,000 power meters, and it got broken. You put in a new power meter that has a new starting value. So it's a replacement issue or a communication issue. Sometimes one current feed or more current feeds are attached upside down. There are normally three current feeds. If only one is attached upside down, you're losing 60% of your kilowatt hour value, so it will giving only 30% of its consumption instead of 100%. And if there are 2 or more, it is likely counting down. It's not connected to DCIM, or there's a customer change during the months in a rack. So you can imagine kilowatt hour value of the end of the month, kilowatt hour value of the beginning of the month. But now in that same month, there are 2 customers. And what we see happening quite often in practice that a colo will say, okay, we're not going to charge any of our customers for that month. That month is free of charge. And that's also a lot of income. So what we have found out in reality that if you add them all up, and in general, co-location sites are losing 5 or 10% of the turnover, and sometimes even more, due to all these issues. And of course, if you had a very big step, and you send a large invoice to a customer and to argue with you, how's it possible? And you have to admit, okay, you made a mistake. You see that you're losing customers due to lack of trust. That's one issue. How do we cover them? Just one example. This is a small picture from our system, and it's a technical picture, but it gives a lot of information. Here at the bottom right part, we see that there is a rack. So these are 2 bus bars, bus bar A, bus bar B, with 3 feeds, 1, 2, 3, 1, 2, 3. And here we can see at bus bar B, feed 1, there's power consumption, but there's no customer and there is no contract. So somebody is using power without paying for it. Here we have a comparison between the sum of the underlying PDUs and the main PDU. And if you see some differences, we know, okay, there's a power meter not rightly connected. There's a power meter wrongly configured. There's something attached to a wrong feed. So something is wrong. So you know that something is wrong in this bus bar, and you should find those errors and make sure that these values are 0, 0, 0. And here we look at redundancy. So if you have a failover, do you still have a redundancy? Or does a failover result in an outage? So as a colo operator, do you have to check all those different underlying things? No, you don't. So what did we do? if you look to our application in general, we start with the contracts. The contracts can be in an external CRM or our own CRM application, and we integrate those contracts into our system. And we attach those contracts to a rec, and we aggregate all those kilowatt-hour values on customer level, regardless of the number of recs he's using, or like the example of interaction, they were a customer regardless of the number of locations they're using. And then we sum them all up, and we can send the information to finance via an Excel and other format, or sometimes we can integrate with their database. So for the result, is everything okay in my data center? You can check at the invoices. So this is the application of invoices. You can see 4 different customers, their values, and you also see some green, red, and orange dots. So what did they say? All those consistency checks will also add up in this report. So the green dots will say, okay, everything is okay. You can send invoices to the customers without having an issue. They are okay. The orange one should be checked because we found some smaller items and that end up in a less than 5% deviation in data. And the red will mean we found some serious errors on the data. There's something really wrong. To give you some idea here, you can see there's a kilowatt-hour value usage and there is no kilowatt-hour value measured. So you can imagine that something is wrong. But all those underlying checks we do at the system do end up in this just one report. So this report helps to save you, to increase your income a lot. Now talking about data center performance. As you might know, that within the data centers, there's a holy grail metrics designed by the Green Grid, and it's called PUE, Power Usage Effectiveness. So the PUE, if you want to calculate it, it is very simple. It's total power divided by IT power. So you can imagine if total power divided by IT power is 1, it's an optimum situation because you're not putting power in anything else. If it's 2, then 50% of your power is going to IT and 50% is going to your infrastructure. This is the latest sheet from the uptime. They yesterday had a 2022 reporting event. So these are the pictures from yesterday, actually. And if you look to the PUE worldwide, you can see in the year 2007, the worldwide PUE was 2.5. In 2013, it has decreased to 1.65. But since 2013, it has flatlined. So there has hardly been any improvement at all. So nowadays it's 1.55. It's just slightly less, but you can see in 2019 it decreased again. So there isn't any progress anymore. So why is that? If you look to data centers and what is important to them and what they report, you can actually see there are 2 major ones. One is the power, the PUE. So 75% of the data centers look at PUE and 85% look at total power consumption. So you can imagine colos are mainly managing PUE and privately owned data centers are using total power consumption because it's more important for them. And the other ones are less important for them because actually it's only about saving costs is the driver for managing things and not the other parts, which is quite a shame and a risk because if you look to the new directives that are coming, new legislation are coming, the other ones should also be taken into account. Okay, PUE. So we also have a PUE display showing you some PUE, IPUE that show the 30 seconds average, the yearly average, etc. So that's okay. Okay, this is another true-based story from one of my customers, and they had an actual PUE of 1.46. So this was the data center, and if you calculate it, you will come to this value of 1.46. Then the local administration came to the data center CEO and said to him, your PUE is now 1.46, but it has to be within 1.3 because in our region, that's the limit, and you have 12 months to correct this. So bring your PUE back to 1.3, otherwise you have some issues. We won't accept it. So the CEO went to the facility manager and he said, well, we must improve our PUE because now it's 1.56 and it has to become below 1.3. And you have several months to do it, but make sure it's arranged before the end of the year. Otherwise, we have some issues with our local administration. So looking at PUE 1.46, the green grid also had a trick, and they call it decomposition of the PUE, partial PUEs. And you can see this data center has two rooms, room 1 and room 2. And if you look to the partial PUE of room 2 is 1.62, the partial PUE of room 1 is 1.25, and the general losses in everything else is 0.1. So the facility manager did look at his data, and he said to the CEO, well, if I look to my EMS, my energy monitoring system, tell me that my best part of my PUE is 1.32, because a part of this has to be added to this one to get a good value, and my worst is 1.65. I have no idea what to do, how to improve it, because a couple of years ago we already made a big step. So when we did cold aisle containment, and if I look to my cracks, which are using the most energy, they're optimized by my vendor, and they have a control setup. So I think if you ask me the question, I have no things to do anymore. But if I look to the design PUE of the data center, it was only 1.25. So that's below the PUE we needed. So actually, I think you should talk to sales, because they should have more load, because room 2 is very empty. And if you increase load in room 2, that will definitely improve our PUE. So to be honest, there's nothing I can do to help you. Talk to sales. Okay, if you look to answers on your questions, how to improve, you need, of course, a monitoring system. And what we see in reality, that data centers are using different systems for different functions. So they have a system for energy, a system for cooling, a system for building, and so on. By the way, this is our system. I will go into depth a few slides later to tell you more about it. But it's, in general, they're using different applications for different functions, because, well, if you have a different CMS, it's much more resilient than having an integrated system and so on. But in reality, you need an integrated system to do more and to make more steps. So we have an integrated system. For us, it's just one system. Everything is integrated. So if you have an integrated system, you can make, we call it a balanced scorecard, bring all domains together. So the PUE part, the cooling efficiency, the capacity part on the cooling and UPSs, and also the SLA contracts. So this is the balanced scorecard I made for the data center we just talked about. So where the facility manager said there's nothing I can do. Sales should sell more. Okay, looking to this balanced scorecard, we can see that the SLA contracts are fine. So you can imagine if you have a big big cloud customers, the SLA is very important, because if you breach your SLA, your penalties can run up over $1 million just for one breach. So that's a very important part. But looking at this balanced scorecard, I can see several things. Of course, my PUE is too high, because it should be below 1.3. But to start with the cooling, I see that I've lost my redundancy on room 1. So my capacity need is 83%. My total cooling capacity is okay, 60%, but I've lost on room 1, and I have a lot of capacity still available on room 2. I also, if I look to the efficiency of the cooling, I can see that my ER, so this customer is using DX, is direct expansion units, and I think a DX unit should be above and have an ER above 7. So if you look to room 1, it's 8, that's okay. But if you look to room 2, it's 5.2, which is way too low, which also results in a too low ER of the rooms together. So step 1 I'm gonna make is I'm gonna make sure that I'm gonna get my redundancy back in this room 1. And there are 2 ways. Of course, I can add a new crack unit, which will bring me a new CAPEX and new OPEX costs. But I can also have a discussion with my customers and move some equipment from room 1 to room 2. So that's what he did. They moved equipment from room 1 to room 2. So this is a new situation. So 22% of the equipment is moved. So the N+1 is back again. So the redundancy is back again. And you can see that the load of room 1 is 61% and the load of room 2 is 59%. So still that's 60%. And actually that's perfect. And what was the result next to that I've gained back my N+1 redundancy? my EER has improved for both room 2 and room 1. Because if you look, so it's above 7. If you look to the crack unit, a crack unit runs most efficient if it has a load around 60%, because the current rise of this fan is not linear to the speed. So if a fan runs on around 50%, it's only be using around 50% of its current, and then it will rapidly be rising. So this movement of equipment brought back redundancy, improved cooling room efficiency, and almost brought my PUE within target. It's just slightly above target. So my target 1.3 is 1.31. And you can see I've lowered both my room 1 and my room 2 PUE. So I'm almost there. Again, looking to this slide, I can see there's something else wrong, because I still some red items, and that's now about my UPS capacity or my UPS efficiency, both. So if I look to my UPS efficiency is only 87%. But if I look to my load on my UPSs is very low. So it's 18, 23, 19, 36. So in general, 27, 35, 29. So I should do something about that. And what will that bring? So looking to UPSs, so this is coming from the Energy Star. So you can see that the UPS efficiency will decrease when your load is lower. And data centers are sometimes very proud that they have a low load on the UPS, for example, 30%, because then they have a lot of battery resiliency, and they can say, well, we can run on battery capacity for 15 minutes. But actually, what they are telling you, we are wasting a lot of money on our capacity on UPSs. So they should improve that. Of course, you can buy better UPSs. So nowadays, if you go to the new Mitsubishi UPSs, they have a very different, higher curve, but still it will go down a bit when the load is lower. So the idea is we should improve our load on our UPSs. So I've drawn those two squares. This is the first UPS, so it's only has an 85% efficiency. This my second is 92%. So what you should do is otherwise decrease your capacity, just put some UPS offline, that your load will be increasing. So that's what we did. And there's another thing is, if you look to currents like here, you can see you have an unbalance. So this is the actual currents being used. These are the failovers. This is also coming from our system. And this imbalance will also result in zero currents, and zero recurrence will result in losses. So two steps to be make: balancing and increasing load. So next step, if you're going to increase and balance your load, so just detaching the part, your efficiency will increase from 87 to 94%, and that will increase your general partial PUE. And now we are just below, way below the targeted PUE of 1.3. Do you remember that sales said, oh sorry, facility manager said, there is nothing I can do? Well, he was right, because he didn't have the tools to do something, but there was a lot he could do if he had the right tools. So show me the money. What does it bring, those steps? Of course, first of all, you have compliance with your legislation, so your PUE is below 1.3. But going back to just a smaller, bigger co-location sites, so you have small, medium, and bigger co-location sites. I think the bigger stand around 10,000 square meters, and they run up to maybe 200,000 meters. So this one is a 12,000 square meters co-location site, so not very big. It uses 50 megawatt, and they pay 10 cents per kilowatt for their energy price purchasing. They had a PUE of 1.4, so the yearly energy costs will be $13 million. If this PUE 1.46 is low to 1.25, which was also a demand from the legislation, the energy consumption, this 15 megawatt, is decreased to 12.8, and in the yearly energy cost is 11 million. So they're roughly saving $2 million yearly on energy consumption. The other part is, if you look to the missed turnover, the selling price of kilowatts for your customers 25 cents. So based on this site, they have an IT load of roughly 10 megawatts. That means they have a turnover of $22.5 million yearly based on the energy they're selling. But if you miss 5 to 10%, they miss somewhere between 1.1 and 2.2 million. So for example, let's assume that they somewhere in the middle, they lose 7.5%. That means those two steps will bring a turnover increase of 1.6 million, an energy cost saving on 1.9 million almost. So the total benefits of those two steps is 3.5 million. So even if you buy a more expensive DCM, your ROI on DCM will be around 2 till 3 months. So going back to my very first slide, how are we going to pick and choose the DCM? Is it really counting the features and say, okay, invoicing, end month, beginning months, times cost, that's it? Or are we going to go more in depth and take other points to decide which DCM solution you're going to choose? So if you really want to have a DCM solution that will fit on your needs, you have to know, okay, which issues do I need? What do I need to solve? So you have to understand your operation. What do we need for reporting? What do we need for everything? And of course, if you buy a DCM, don't aim for things nice to have, but look at either, okay, how can DCM help me to improve my operation, to decrease my human resources needed? So actually ROI saving items. So, sorry. It's more about invoicing, contract management, SLA management, remember the penalties, performance optimization, improvement. Maybe you would like to sell hands-on to your customers, so you need information for your hands-on. Preventing outages. The new report from the Uptime Institute yesterday said that still they had now around 900 respondents. They still had 70% of them had an outage the last 3 years. So outage is still a big issue worldwide. Improving your maintenance, so switching from reactive to proactive, reducing you needed staff, alarm management. So please make a list of what you really, really need and decide which DCM you're going to buy based on that. So your DCM should fill in your gaps and your needs. But please, what's very important and what's often forgotten is to train your people, because just buying a DCM, say, okay, now we have a DCM, that's it, won't bring you the benefits you're needing. So if you train your people to understand what they're doing, to understand how to use a DCM, that will bring you benefits. And then you can reach that 2 to 3 months ROI on a DCM product. And then you will be earning a lot of money because you have bought a DCM solution. So looking to our solution, you've seen this picture before. So actually for us, it's just one software package. So it consists of functional modules. So it's energy management, cooling management, building management, and it's one application. So it's integrated. So it's very easy to have an integrated balance scorecard as I was showing you. It comes to performance management, capacity failover, and invoicing. And you have seen that even a simple process of invoicing is in reality very complex because there are so many things that can go wrong. We have something for white space optimization. And then if you have a privately owned data center, you need rack, cable, and patch management, IT management. That's what we do with third-party products. And of course, you have to integrate to maybe maintenance, CRM, ticketing, finance, etc. So we can deliver a complete DCM suite that will fit your needs. So my idea is always that if you want a DCM, look at your needs, look at your worries, and ask maybe a proof of concept. Okay, these are my worries. How did you handle this? Can you show it? So our DCM solution, by the way, is open. It's a software product, so we don't need hardware products to communicate with devices. So we can connect to any device and any protocol, only on software. It's scalable. So the interaction side, it's around 12 sites. I don't know how many users, maybe 150 users, maybe 3-4 million data points. It's quite big, but it can also be small. And this is our real secret. So what did we do? We built a rapid development tool, a rapid deployment tool. So our solution is, the framework is coming from Mitsubishi Iconics, and we built a rapid development tool to deploy our DCM solution on top of it. In this framework, there are 1,400 different building blocks, and just one power meter is one of those building blocks. So if you want to monitor and invoice and everything on one power meter, you only need two modules. You need the invoicing module and you need the power meter module, and you just have to fill in the IP address, the BMS code, the graphic. That's more or less it, and then you generate that power meter into your application. To give you some idea, so this is our rapid development tool. So we generate the application, we generate graphics. If we don't have the device yet in place, we have a rapid development tool for generating new items. And if you look to Schneider, we have 68 library elements from Schneider, and we already have deployed them 168,000 times. Just some graphics, white space, cracks, general overview. It's 2D, 3D, HTML5, whatever. The single line diagram with the transformers, the gensets, the swing sets, the UPSs, breakers, the cooling part of the system. And just two references, this is just one. This is an older picture, but it's also on the site of this customer. It's LCL, it's a co-location site in Belgium. They have 5 locations and they're using our system nowadays. So this is showing only 3, but at the moment they have 5. And they use our system for everything. So it's about reporting, it's about performance, it's about invoicing, and you can, from each location, you can look at all those locations and they have an overall reporting. And this was the one who was Rick working for, so that's Interaction. It's a very, well, they have in Netherlands 12 sites, worldwide around 200. So this can be found on the control engineering Europe.com. So there was an article which has been written. So some other ideas about customers. So I already mentioned Interaction, Bulk, Facebook, Amazon, Northeast, Switch, Digital Realty. So we have some Microsoft. We have some very nice customers who are using our DCIM application. Okay, that's it for me. Are there any questions? Please, if you can type in your questions in the message area, in your communication box, and either Rick or I can respond on them.
It's with you, Patrick.
Martin, I see a few questions, so I'll go ahead. Okay, so the first one is, why did you choose Iconics as the framework for your DCIM application?
Yes. Well, actually, when we started around 2007, we were looking to a framework, a real-time framework, which will serve our needs, but was also a state-of-the-art framework. And also, if you look to the organization behind, that who would help us, and we're also flexible. So we looked at different vendors at that time, and we have a talk with the owner also of Iconics. And Iconics was very really on the edge of technology, really more advanced than the other ones. And for us, it was also possible to have influence on their development. So the ideas we had, we could share them with Iconics, and they would also make something available for us. So we were able to produce our solution. So it was a mixture of state-of-the-art products and having a good contact with development and being and a group that would help us with issues if they occurred. So that's how we came to Iconics. And like I said, we did over 200 implementations already with them, and so we are very happy with the partnerships. And nowadays, Iconics is part of Mitsubishi Electric, and that's even for us much more nicer. Rick, I don't know if you want to add anything or.
Well, yeah, it is true that's pretty much as a from a customer point of view, a bit similar to why I chose Iconics as well. It is the flexibility that you have and the open source protocols that it's using is very beneficial. And indeed, now it's part of the Mitsubishi family, so we can back it up with even more power, a larger company to support all the needs and the development to grow.
Okay, I just another question. So, Martin, you said you started with one type of device and ended on a full-scale DCIM across multiple data centers. So, how about scalability?
Yeah, it was one of my slides. It's actually very, very scalable. It's true that we, before we were entering the data center market, so before 2007, we were being an industrial process control company. So we are doing project for DuPont, Unilever, Shell, that kind of companies. And how that worked, they come with a specification to us. We made a quote, we do the project. And so this is how we started in the data center. So we started actually Interaction as one of our first customers, and we started with the invoicing part. And they had some boxes from Belco, it's a Chinese manufacturer. And they wanted, okay, we have those boxes and we would like to send invoices based on the customers, based on the power consumption measured by those boxes. Can you help us with that? So this is how we started that. And when that was working and finished, they said, okay, if you can do this, can you also do this and this and this, this? And this is how the application did grow in the beginning. But the advantage of Iconics is you don't have really any limitations, because if you look to many other brands, you need a PLC, and a PLC has a maximum capacity, and then you can attach some devices, and then you will run into limits. But in the case of Iconics, you just can expand service. So we have application service, and if one is full, you put in the next and the next and the next and the next. And on top of that, there's just one uniform platform. So going back to Interaction, the biggest site at the moment, they have 14 servers, but they have over 100,000 devices attached to it in real time, and so it can grow. I don't think there's a limit. Well, of course, per server, because a server, if it has enough data points, you have something about performance. So we say if you have 100,000 data points on the server, or maybe 150, then we go to the next server. So it's very scalable, and we haven't seen the limit yet. I don't know, Rick, if you want to add on something.
Yeah, it's with Interaction, like Martin stated, we had a Chinese branded Belco box, which gave us a bit of headaches to read out. And it wasn't really the plan to really have a complete DCIM solution in our data center. We just want to have that one problem solved. And because Iconics has open source protocol, it really helped us to get that in. And then, like Martin said, when I learned more about Iconics, I asked Martin, well, okay, I have more devices. If it's open source, can we add it? Martin just said yes to pretty much all of my questions. So every time I went into the data center and had trouble with, well, actually pretty much time management, just because I needed to walk around the data center a lot to find all kinds of issues and do control rounds to make sure that everything was working. I was every time thinking, when I was looking at a device, can I add this as well? So every time, especially in the first year, I just called up Martin. Hey, Martin, I'm in front of this device. And he just guided me. Yeah, well, is there an Ethernet connection, RS485 connection, or anything else? And if so, I could connect it to the network, made sure that it was running. We found the registers and got it into the system. And that's how it gradually grew into a complete system. And of course, you at first you think, well, I just need a small system. Well, am I going to run into any issues when I'm growing so rapidly with so many devices? Because when we found out how to connect one device, we immediately added the same device, which we had maybe 50 times in that same data center. And then along the way, of course, you want to add more data centers. Well, how are we going to do that? And without changing the system, without changing server platforms, or I needed to go to a different version, or any kind of stuff like that. It was really easy just to add more. And yes, I had to buy a new license to add more tags to it, but it was without changing the complete backend of the system. So it was just adding. So it was really easy to scale up for us cross data centers, but also just to add more devices. And like Martin said, it's when you hit the limitation, you will hit the limitation of a server, and then you could easily just add server for the application side. And everyone who was using the system in our data centers, like management, engineers, finance even used it, sales used it, customer implementation teams used it. They never knew, they never saw it, because for them it was only one system to look at everything in the data center, and it helped us a lot, even though that it's not anymore the separate systems. So every user just needed to remember one web link, and they could have the view over all the data centers at the same time.
Okay. Other question, Megan?
Do we have any more questions? If anyone wants to ask anything, I do see. Okay. Question. Okay, what's the question? Right. How are we addressing the user problems with regards in using DCIM? And one issue with experience is to integrate the devices, especially finding the right DDF file and MIB file. How do you address this?
Yes. Well, sometimes that is not very easy, but I think the world becomes more open. So in the beginning, especially in the beginning, it was sometimes very difficult to retrieve the information, because not all the vendors would like to be open. And then in that case, we would ask customers, well, can you please help us to get that information from the customer? And sometimes we just use a protocol analyzer. If nothing is available, we put a protocol analyzer online. We see what's communicating, and that's how it's treated. But that's more old days technology. Nowadays, everything is available. And to be honest, we never had any device to which we could not connect. But I know in the past, sometimes it will take us a week to get something connected. But nowadays, also with our tooling, we do manage within 2 to 4 hours to have a complete device up and running. So it was in the beginning difficult, but nowadays is going much more better, and most of them are complying to standards. So maybe to the BACnet standard, to the Modbus standard, or whatever. But so that's it. And what we also do, if you look at our application, we never build anything because we think it's nice. We have some very high demanding customers, and that's very nice because they help us a lot to develop the tools that customers do need, like that invoicing part. We also made the mistakes in the beginning and think it was very simple, end month, beginning month, invoice ready. But those customers helped us to find all those issues and to find solutions for all those issues. So we talk a lot to customers, we listen to customers, and now if you look to our standard invoicing, it will tackle all those items which I did mention. And I think at the moment, I think we've everything covered which can go wrong at the invoicing process. But that is just listening to our customers, making the right steps, testing it to customers. But you need some high demanding, difficult customers to build an application like this. I hope this will answer those two questions.
Fedma, does this answer your question? You can also unmute yourself and ask if required anything. Yeah. Okay. Great. So do we have any more questions?
Okay. I think if there are any more questions, please reach out to Rick or me. You can find our telephone numbers or our email addresses on this page. You can make a photo of. But I think this presentation will be made available to the attendee or not, Mega.
Yeah. I'll send over these to all the registrants as well, because I see few people could not attend it, but yeah, these will be available to all the attendees as well as the registrants.
Oh, that's good. That's good. So in that case, if you have any question left, just send us an email or give us a telephone call. Yes.
Sure. Thank you so much, Martin. Thank you, Rick, and thank you for everyone who joined today.
Thank you, everyone.
Thank you all, and have a nice day, and hope to meet you face to face in future when we are going to work together. Have a great evening. Bye bye.